Okay, fifth graders, today we are skipping module 4, lesson 4. Yesterday we did lesson 3, right? We're going to skip lesson 4. We're going to move right to lesson 5 because I think that we are ready for lesson 5, okay? Lesson 5 is about using tape diagrams to help us solve word problems. So today, as you can expect, we're just going to be solving word problems. Not just. We are going to be solving word problems, but the important thing we're focusing on is how we can use a tape diagram to represent the word problem and how that can help us solve it. Make sense? An example of this kind of problem is your problem of the day. It says 4 grade levels need equal time for indoor recess, and the gym is available for 3 hours. Okay, this is at a school where I guess we don't have indoor recess in our classrooms. Instead, we share it in the gym. We share the space in the gym. Okay, how many hours of recess will each grade level receive? How many minutes? So of course, the question's asking us to figure out how many hours each grade level can get, and then also how many minutes can they get. The important information is that there are 4 grade levels, and they need to share the gym for 3 hours. Okay, so if we're drawing a tape diagram to represent this, we need to show that the piece of tape is all of the time that the gym is available for. How long is the gym available for, everyone?
3 hours.
Good, so we're going to label it as 3 hours. Now we need to share those 3 hours equally into groups, depending on how many people or how many groups of people are trying to share it. How many groups of people are trying to share it? 4. So I have to divide it into 4 equal-sized pieces. And we're trying to figure out how much one person or one grade level can get it for. Okay? So what math equation are we doing here? Now that we've drawn our tape diagram to represent it, what math equation do we need to do?
4 divided by 3.
So are we taking 4 classes and dividing it into 3 hours? No, think carefully. What's our whole here? What's the whole piece of tape? 3. So be careful. I love the fact that Maham said 4 divided by 3 because a lot of times that's the most common mistake to make when we're solving these kinds of problems. This is why a tape diagram helps us. We always divide the whole, right? And what's the whole piece of tape? 3. So the whole always comes first. And we're dividing it into how many groups? 1, 2, 3, 4. So what's our divisor?
4.
So we're doing 3 divided by 4. Well, based on our work this week, we know that 3 divided by 4 can be written as a fraction. 3 divided by 4. So what's the answer? 3/4 of an hour. Because right now, our units are in hours. So for the first question, how many hours of recess will each class receive? The answer is 3/4 of an hour. Okay. But then the second part asks how many minutes. How many minutes are in 1 hour?
60.
So that means I have to make the denominator into 60 to find out how many of those minutes they can have. So we have to think to ourselves, what version of 1 should I multiply 3/4 by to get to some number of 60ths? 3 times what will equal 60? How can I figure that out? 3 times blank will equal 60. How could I use inverse operations to figure out what that blank should be? Taya? 60 divided by? Oh, sorry. Yeah, but actually you're right. It should be 4, right? Because we're doing 4 times something will equal 60. So 60 divided by 4. What is 60 divided by 4? Everyone? So what version of 1 should we multiply by?
15.
15 over? Good. So we know that 4 times 15 is 60. What's 3 times 15?
45.
So how many minutes could they each get it for?
45 minutes.
Very good. Okay, so it says, when someone donated 16 gallons of ice cream to Stockholmare Elementary School, they decided to have a huge party. 16 gallons of ice cream, that's a lot. They split those 16 gallons of ice cream equally among 6 classes. The first question is asking us, how much ice cream did each class get? The important information is that there are 16 gallons of ice cream, and we're splitting it equally among 6 classes. Take a moment to jot down that information. Then, draw a tape diagram. Don't solve it yet. Just draw a tape diagram that represents this. So to draw a tape diagram, we know that all together, how much ice cream do we have?
16 gallons.
Okay, good. 16 gallons. And we have to split those 16 gallons equally into how many sections? 6 groups, right? Because 6 classes want to share it. And we want to find out how much one class is going to get. The hardest part of this is figuring out what is the whole and what is the divisor. Okay. The whole is how much we're starting with. How much are we starting with?
16.
16 gallons. Good. So our whole is 16. We're dividing that 16 gallons into how many groups? 6. So our division equation is 16 divided by 6. How can we write 16 divided by 6 as a fraction?
16.
Maria?
16 6.
16 6. Good. Are there any holes hidden in there?
Yes.
How many holes are hidden in there?
2.
Good. So when I take out 2 holes, how many 6 are left?
4.
4 6. Could I simplify that?
Yes.
What is that equal to?
2 and 2/3.
2 and 2/3. What's my units?
Gallons.
Good. So each class gets 2 and 2/3 gallons of ice cream. That means that this class gets 2 and 2/3 gallons. This class gets 2 and 2/3 gallons, etc. for all 6 groups. So then the next question is asking, how much ice cream will 4 classes eat? Okay, well, how could we draw a tape diagram to represent that? We still know that all together we have 16 gallons, and it's been shared by 6 groups. But this time we want to know how much is being eaten by 4 classes, not 1 class. Based on the information that we did in part A, we know that each class is getting 2 and 2/3, 2 and 2/3, etc. So how can I figure out how much 4 classes are eating? What equation would we need to do in order to figure that out? What do we need to do? Vikaksh?
2 and 2/3 times 4.
Very good. 2 and 2/3 times 4. But have we learned how to multiply fractions yet? No. Does that mean we can't solve this? No. Luckily, we know that multiplication is the same as?
Repeat addition.
So this is the same as 2 and 2/3 plus 2 and 2/3 plus 2 and 2/3 plus 2 and 2/3. Using the commutative property, we know that we can add up all the whole numbers first. What's 2 plus 2 plus 2 plus 2?
8.
Okay. And then we can add up all the fraction parts. 2/3 plus 2/3 plus 2/3 plus 2/3. What is that? 8/3. Good. Are there any holes in 8/3?
Yes.
So really, this is 8 plus, how many holes are there in 2/3? 2. And
2/3.
so what's my final answer?
10 2/3.
What's my unit? Gallons of ice cream. Very good. Don't forget the units. 4 students are trying to share 15 cookies evenly, and we want to find out how many cookies each student will get. Okay, so start by drawing a tape diagram. Do we have 4 students that are being shared by 15 cookies?
No.
No. So be careful. Again, this is the easiest part to mess up. Okay, what is being shared evenly, everyone?
The cookies.
How many cookies?
15.
Good. And they're being shared by how many people?
4.
So I have to divide this into 4 groups. And with our question mark, we can show that we're trying to find out how much each student will get. So, what math equation are we needing to do? 15 divided by 4. Once I know the division equation, I can easily convert that to a fraction, 15 over 4. And when I do that, I can just ask myself, how many holes are in there? 3. Okay, and then how many fourths are left?
3.
Each student will get 3 3/4 of a
Cookie.
cookie. Good. That means that this student gets 3 3/4, this student gets 3 3/4, this student gets 3 3/4, and this student gets 3 3/4. Right? Do you guys agree? Part 2 is asking, what fraction of the 15 cookies will each student get? What fraction of all the cookies is this student getting?
3 3/4.
Well, they're getting 3 3/4 cookies. But is that a fraction of all the 15 cookies? Talk to your table group. What is the second part asking us? It's asking what fraction of what?
15.
Of the 15 cookies. So if I had all 15 cookies, what fraction is each student getting? Is each student getting 3 3/4 of all the cookies?
No.
Would that make sense?
No.
Is each student getting 15/4 of all the cookies?
No.
Each student is getting how much of all the cookies? Mira?
1/4.
Each student is getting 1/4 of all the cookies because 3 3/4 is 1/4 of all 15 cookies. So this question isn't hard to solve. The hard part is understanding what of the cookies means. This question is asking, out of all the cookies, what fraction is each student getting? This question really reminds us that we have to pay attention to the wording of the question. The first part is saying how many cookies. So we want the actual number of cookies. But the second question is saying what fraction of all the cookies. We have to think of the 15 cookies as one whole. What fraction of the whole is each student getting? Okay, so you really have to read the question carefully. What is this question asking us to find? We need to find out what is the minimum amount he must save each day in order to reach his goal. We know that he's trying to save $45 altogether, and he has 6 days to do it. Okay, go ahead and draw a tape diagram that represents this problem. So whenever we're drawing a tape diagram, we have to think all together, how much do we have? Well, he's trying to save $45. That's what he wants to end up with. But he's going to save that in over the course of 6 days. Right? So we're dividing 45 into how many groups?
6.
So we're doing 45 divided by 6. How can I write that as a fraction? Do you guys see how once you know the division equation, once you know what the whole is, and once you know what the divisor is, it's very easy. Is the whole always bigger than the divisor? Look back at the problems we've solved today. Is the whole always bigger than the divisor?
No.
No. If the whole is smaller than the divisor, what happens? We just have a fraction that's less than 1. Is that okay? A very common fabulous fail. Listen carefully. People who don't know math that well, they always assume that the bigger number is the whole, because obviously you have to have a bigger amount so that you can divide it into smaller groups. Is that always the case? Could I have 1 divided by 2? But the 1 is smaller than 2. Is that okay?
Yeah.
What would the answer be?
1/2.
Yeah. Can I have 5 divided by 6? Yeah. Even though 5 is smaller than 6?
Yeah.
Could I also have the whole be bigger, like 45 divided by 6? Yeah. If the whole is bigger than the divisor, what does that mean my quotient or my answer is going to be? Greater than 1 or greater than. Or I guess if the numbers are the same, then it'll be exactly 1. And if the whole is smaller than the divisor, the answer will be?
Less than 1.
So those are all possible, right? So don't fall into the trap where you think, well, obviously the first number needs to be bigger. Oftentimes, people who aren't that good at math, that's what happens. Okay, so if I know that my whole is $45 and I'm dividing it into 6 days of saving it, what is my fraction? 45 over 6. Good. How many wholes are in there?
7.
How many 6 are left?
3, 6.
I know, I see it. 3, 6, right? Okay, so if the answer is 7 and 3, 6, how can I write that in a simplified version? 7.5. So that's $7.50, right? Right? Okay. But the answer tells us to express our answer in dollars. Follow along with me. I know you can't see it on the screen right now. I'll deal with that in just a second. How much is $7.50? 7 and good, $7.50. He needs to save $7.50 each day for 6 days in order to reach his